Hello students, in this module we'll be studying about the kinematical equation, which is very important topic from examination point of view. Fine. Now let's just consider a situation. Fine. Suppose we have a body which is already moving with the initial velocity u. Fine. Is already moving with the initial velocity u. Let this be point A. Now it has been accelerated by the value a such that the final velocity becomes v at point B, and the time taken by the body from u to v, let that time be t, and the associated displacement be s. Now students, we have to plot this complete information onto graph. Fine. So how we'll be doing that? By making the velocity time graph. This is the VT graph, students. Now consider the VT graph of an object that moves under uniform acceleration. Now here u is not equals to 0. It has some value. Let that initial velocity of the object somewhat here. Fine. This is the initial velocity of the object. Let this point be O. Now at time t, let that time t be here. Fine, at this point. So at time t, the velocity has been increased. Fine. Now you just have to join these lines and finally draw perpendiculars from this line. Fine. So I've joined this line with this. You can see here, this is the initial velocity. This becomes the complete final velocity of the object. This point is B. Let this point be B. Let this point be D. Fine. Join this line. We are doing a construction here. Now students, with the help of this graph that we have made here, we have plotted each and everything fine according to the given situation. Now students, let's just derive the first kinematical equation with the help of an acceleration. Fine. So we know that velocity, when we divide it by time, we get the acceleration. Now with the help of this definition, that is a is equals to change in velocity upon time. Fine. We can easily get the first kinematical equation by this definition, that is acceleration. Now students, here acceleration, change in velocity is the final velocity minus initial. Fine. Divided by time. So what is the final velocity here, students? Final velocity is BD. Fine. And your initial velocity is, let this point be A, students. Fine. This is A point. This is A point. So this initial velocity is AO. Now what is time here? It's OD, represented by the OD. This D point. This is D point, students. Fine. Now just simply put the values. Acceleration is equals to BD. BD is V. Put this value minus AO. AO is U. Write U here. Then OD is T. Simply write it T. Fine. Send this T to this side. We get AT is equals to V minus U. This is a negative. Fine. Send this to left hand side. We get V is equals to U plus AT. This is what the first kinematical equation. Fine. I hope this thing is, you can easily see now. AT is equals to V minus U. Then it becomes V is equals to U plus AT. This is the first kinematical equation, students. Very important, and you have to note down this complete thing in your notebook. Now moving on to the second kinematical equation. Now students, in velocity time graph, the area, basically the displacement S is given by the area. Fine. This is the area. Right. So Here S displacement is area, fine. So with the help of this S, we can easily derive the second kinematical equation, and displacement is given by the complete area. Here you can see what it becomes, the trapezium ABDO. So here S is equals to area of trapezium, that is ABDO, fine. And what is the area of trapezium? That is half into sum of parallel sides into height, fine. So simply put the values. Half, parallel sides are AO and BD, fine. These are the parallel sides. Simply writing them, AO plus BD. What is the height, students? OD, fine. OD is the height. Now half into, simply putting the values, here AO is equals to U, BD is equals to V, and OD is equals to T. So we can write it as T here. Now can we write T as V minus U upon A? Of course. How? With the help of this formula, that is A is equals to V minus U upon T. We know this thing? Fine. So with the help of this, we can easily get the value of T. And how? T is equals to V minus U upon A. Fine. T is equals to V minus U upon A. Just put this value here. It becomes half into, can we write it as V plus U? Fine, of course we can. So V plus U, T is equals to V minus U upon A. Simply writing it as V minus U upon A. Fine. Now student, here you can see we can send this 2 in A onto this side. This get multiplied by this S. So we get 2 AS. Fine. 2 multiplied by S in A, we get 2AS. And here the identity is being applied, that is A plus B, fine, and A minus B. So we get A square minus B square, that is V square minus U square. So this is your second kinematical equation, that is V square minus U square is equals to 2AS. Very simple, students. I hope it is clear. Now moving on to the last one. Here also we'll be applying the same formula, that is displacement. It is given by the area of trapezium, that is ABDO. But what we have to do here, students, here you can see that the complete trapezium can be divided into rectangle, fine, and a triangle. So I'm just showing you it with a little bit of this color, fine, so that you can easily differentiate between the triangle and rectangle. Now as we have divided this complete trapezium into triangle and rectangle, so just simply apply the area. S is equals to area of triangle, that is ABC, plus area of rectangle, that is ACDO, fine. Now what is the area of this triangle? That is half into base into height. So S is equals to half. What is base here? What is base, students, in this triangle? Base is AC, fine. So simply I am writing AC. And what is height? It's BC, fine. So AC into BC plus what is the area of this rectangle? That is length into breadth, fine. What is length here in this complete rectangle? The length is AO. And what is breadth? It's OD, fine. So simply writing it as AO into OD. By simply putting the value now, it becomes S is equals to half AC is, can we write AC as T? Fine, because OD is also T. So they are both same, we can write it as T. BC, what is BC here? Simple, this is U, this can also be U, fine. Now subtract this complete from this, we get this one, fine, that is V minus U. So this BC becomes V minus U. Plus AO is U, so we can simply write it as U, and OD is T. Fine, very simple. Now can we write this V minus U is equals to AT? Of course we can, with the help of this formula, that is A is equals to V minus U upon T. We know this thing, that is the acceleration is equals to change in velocity upon time. So simply just we can multiply this. AT is equals to V minus U. So can we write here AT? Of course. Simply writing it, S is equals to half T. Here we can write AT, then plus U T. Then our complete equation becomes like this. S is equals to UT plus half AT square. So this is what the third kinematical equation. I hope I'm clear to each one of you. Thank you.